Perfect. Happy Friday. It is 7 p.m. So I am going to go ahead and get this started. My name is Lauren Stutz, and I will be hosting tonight's open house for the AP Chemistry semester long review session. And I'm so happy that y'all can join us this evening. I'm going to go ahead and share my screen. All right. So let's get this started. Again, my name is Lauren Stutz, and I have been an educator for the past 10 years. I graduated from Mississippi State University, which is in Mississippi, with 2 degrees. I went ahead and did a double major. I received a degree in chemistry and another one in secondary education. So chemistry has been my passion for quite some time, though I did pursue a different path when I went on to grad school at Texas A&M, though it was the Commerce location, not the main campus. And I received my master's in physics. So I'm certified here in Texas to teach 7 through 12 chemistry. I actually started as a graduate assistant in the labs at Mississippi State. And I've been to 3 different schools in the Houston, Texas area since then. Currently, I am teaching at the Kincaid School, which is here in Houston. And I'm also teaching as an adjunct professor at Houston Community College, though I'm teaching physics for Houston Community College, and I'm teaching chemistry over at the Kincaid School. So I am extremely excited to have the opportunity to work with your students this semester as we prepare for this AP Chemistry exam. Now, just a little overview of AP Chemistry, and then we're also going to have a quick overview of the exam. So we're going to meet each Sunday from 12 to 2 Central Time, and this is going to begin on February 5th, and it will end on April 23rd. And then I believe the AP Chemistry exam will be approximately 2 weeks later. So that will be perfect timing. The goal is that this course will help students as they are preparing for this AP Chemistry exam. So this is not meant to be a class where they will learn all new material, but it's meant to be a review and a support for what they're already doing in their classes. That's why one of the prereqs for being in this course is that your student should currently be taking AP Chemistry at his or her high school. Now, there will be a little bit of homework because without homework, we really can't enforce what is happening in the classroom. And without homework, I wouldn't have an opportunity to see what students are truly able to do when no one else is around. So there will be a homework assignment each week, around 45 to 90 minutes. So nothing major. There will be 2 parts to the homework, which I can discuss a little bit more briefly. Okay, so the AP Chemistry exam is one of the longest AP exams that we have. It takes about 3 hours and 15 minutes, though that's the amount of time that it is suggested students use to answer questions. Well, that's the amount of time given to answer questions, not suggested, given. So there's a total of 4 hours when we include all of the other things that happen as we swap sections, for break times, for preparing for the exam. So it is quite a long test. This one is scored just like all the other AP tests on a 1 to 5 scale. So the goal is that students are able to score anywhere from a 3 to a 5, with 5 obviously being the goal that students are shooting for, but a 4 is a wonderful score and a 3 is a really solid score on the AP Chemistry exam. So when students receive a 3, a 4, or a 5, that is generally considered a passing score. There are a few universities that are really particular and require only 4s and 5s to receive credit, but most universities do allow students to score anywhere from a 3 to a 5. So that's what we're going to be practicing for this semester. We're shooting for 5s. Okay, there are two parts to this exam, and that's also going to be represented in our sessions each week and in the homework. So there's a multiple choice section and there's a free response section. The multiple choice is going to be about an hour and a half long. There are 60 questions and it's worth 50% of the overall score. The free response section is a little bit longer, though there are only 7 questions in total. Each question has multiple parts within the question. So, question number 1, a shorter question might just be A, B, C, and D, whereas one of the longer questions might have 7 or 8 different parts to it. So these questions do get a little bit more involved. The free response questions do, but they're nothing to be worried about. And that's also 50% of the score. And as I mentioned, the course and the homework will mimic this. So each week, the homework will have a multiple choice section and it will have a free response section. The multiple choice section is something that students will get immediate feedback on. The free response section, I will actually go in and give each student personalized feedback regarding their work. So there are 9 units within AP Chemistry, and the goal is that we're going to be covering 1 unit per week, and we'll reserve the last couple of weeks for a full review. So we're going to start with atomic structure and atomic properties. We'll move into molecular and ionic compound structure and properties. We'll then head into intermolecular forces and properties. We'll cover chemical reactions, we'll do kinetics, thermodynamics, equilibrium, acids and bases, and applications of thermodynamics. And then again, we will put these topics all together, and those last 3 weeks will be reserved for everything to be mashed into one pile. We won't separate it, and it'll be just a large review of all the material we've covered so far. Okay, so before I go on to the next part, I'm going to pull this back up. I'm going to briefly stop sharing my screen. And I wanted to see if anyone had questions at this point before I moved on to the next part. In the next part, I actually wanted to give everybody just a sample lesson so y'all could see what I would be doing with your students. You can see a little bit of my teaching style and experience some of what your students will be experiencing each Sunday from 12 to 2. But first, are there any questions that I can answer right now? And you can type them in the chat, you can unmute yourself. Any way is fine. Yes, a recording of the class will be provided each week. So all of these meetings are recorded and the recordings will be automatically updated to Canvas in the event that a student is unable to make it. Or if they just want to go back and review the video one more time. Excellent question. Yes, I will do that as well. In fact, the notes for the first unit are already posted in Canvas and are available for students if they'd like to go ahead and download them. And just in case anyone goes into the Canvas course, you will notice that the homeworks are also there, but those are not going to be opened until the class is officially started. So if you try to click on them, you won't actually be able to access the assignments at this point. They'll open up on Sunday, not this coming up Sunday, but the next Sunday, February 5th, when we start the course. Yes, I'm going to be grading the free response questions myself, and I will be providing feedback to the students. So I won't simply mark an answer as incorrect. I will give the student feedback regarding their answer. And especially if I notice a particular question is missed consistently between several students, I'm going to be sure to review that in class as well. Yes, yes. Everything is being pulled from previous exams. So all the free response questions, those are actually old exam questions dating back over the last several years. And then the multiple choice is also, it also mimics the AP exams. Everything down to the instructions for the homework actually mimics it. I encourage students when they're doing the assignments, and they don't know this yet because I haven't had a chance to meet with all of them, but I will encourage them to have a timer right beside them as they're working through the assignments and just see, if this were the real test, how many of these questions would I have been able to do in, 15 minutes? It gives us a really nice picture of each student's strengths and weaknesses and where more attention needs to be focused. So right now there's not a mock test planned just because the course only meets for 2 hours and we would need 4 hours to do a full mock test. Though I believe generally AP chemistry teachers at the high school will give a mock test as the exam approaches. So usually in late April, the AP chemistry teachers will all give mock tests to their students. Okay, and I'll give another moment to see if anyone else has a question, and I'll take more questions after I teach a sample lesson so that y'all can experience what the students will be experiencing. So there will be additional time after that to ask questions as well. Okay. So I'm going to go ahead and share my screen again. Okay. So your students will experience something very similar to this when we meet, though we will be doing more notes. This is going to be one of the example problems that we might work through in class. This has been pulled directly from an old AP exam, so this is also representative of what students could see when they sit down to take the exam in May. We're always going to start by just dissecting the questions and making sure students understand what is expected of them in each question. This one tells us in the boxes below, complete the Lewis electron dot diagrams for each molecule by drawing all bonding and non-bonding electron pairs. Each atom should obey the octet rule. It also lets us know that in the diagram for COCl2, the formal charge on each atom should be equal to 0. So that's giving me some really specific information about how the AP exam wants you to draw this third molecule. So when I sit down to do this, I'll choose this color and I'll make it a little bit larger. Okay, it first tells us to obey the octet rule. So I might make myself a note and remember that octet rule means there needs to be 8 electrons shown for each atom, unless of course it's one of our exceptions to the rule. So when I sit down to do this, I know carbon wants 8, it follows the regular rule, and so does oxygen. Well, if they both want 8, but they can only have however many valence electrons they have, which if we think back to the pattern that exists on the periodic table, we know that carbon has 4 valence electrons and oxygen has 6. So somehow carbon and oxygen need to have a total of 10 electrons between them, with each having 8 total. The only way to accomplish something like that would be to place a triple bond here in between carbon and oxygen. Each bond contains 2 electrons, so this means we currently have 2 here now we have 4, now we have 6. So I would just have to go back and add 2 more electrons here and 2 more here. And that would make, and I'll highlight these, 2, 4, 6, 8. I'm sorry, 1, 2, 4, 6, 8. And then it would be the same on the other side since the oxygen is sharing, 2, 4, 6, and then 7, 8. So this would be our structure for CO. For chlorine, we're going to do something similar. But if I wanted to try this triple bond again for chlorine, let's see if that would even make sense. So chlorine has 7 valence electrons. Each of them do. And 7 plus 7 adds up to 14. Well, if I need 14 electrons to be shown in my structure, and I chose to put a triple bond here, let's see if that would ever work. I already have 6 electrons shown for each chlorine atom, which means I can only add 2 more on each side. If I did that, I would have only used 1, 2, 4, 6, 8, 9, 10 electrons, but I need to show 14. And I can't do that if I choose to use a triple bond. So in this case, a triple bond isn't going to work, and we would have to try a double or single bond. Since I am not, well, since you are likely quite familiar with the Cl2 molecule, we'll go ahead and add the single bond, which is what halogens are usually going to have, like chlorine, fluorine, and bromine. And we'll add the remaining electrons around it. Okay, so we've completed 2 of them. And now for the third one. Now, they gave us this special rule here, and it says the formal charge on each atom should be equal to 0. Okay. So if we remember, or we think back, we need to remember that formal charge is going to look at how many valence electrons an element has. And we would subtract from that the lone electrons plus any bonding electrons there are. So carbon, in its typical state, wants to have 4 bonds. So let's go ahead and draw those. 1, 2, 3. We still need a 4th. And if we think back to our rules, halogens like to only have 1 bond. Well, chlorine is a halogen, so we're not going to give chlorine 2 bonds. We're going to give the oxygen 2 bonds. And this leaves carbon with 2, 4, 6, 8. Okay, so carbon now has a full octet. We can confirm at the end that our formal charge on each atom is in fact equal to 0. Okay, let's go ahead and do the rest of these. So just like we saw over here, the chlorines are also going to have 6 lone electrons. And our oxygen, which already has 2 bonds or 4 electrons, is going to need 2 more. So let's check, let's verify 2 things. Number 1, did I use the correct number of electrons in this structure? And number 2, is my formal charge on each atom 0? If it's not, I would need to redraw this because according to the question, it would not be considered correct. So let's take the information from the other questions. We know carbon has 4 electrons plus oxygen's 6 plus chlorine's 7 plus the other chlorine's 7. And when we add these all together, we would get 24 valence electrons in total. So I need to show 24 valence electrons in total. I have 1, 2, 3, 4, 5, 6. Okay, 7, 8 in this first bond, 10, 11 in this second bond. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. We do have all of those shown. Now we just need to verify that each of these atoms has a formal charge of 0. So if we start with oxygen, oxygen has 6 valence electrons, and then I'm going to add up my lone electrons plus my bonding electrons. So I have 4 bonding 4 lone electrons. Those are the little dots on either side of oxygen. And I have 2 electrons that are participating in bonding. Well, 6 minus 6 is 0, so oxygen has a formal charge of 0. We can confirm this for chlorine as well, and whatever happens with this chlorine is also going to be true of the chlorine on the right because they are symmetrical. So chlorine has 7 valence electrons minus, okay, it has 1, 2, 3, 4, 5, 6 lone electrons plus 1 bonding electron. That equals 0. So both my chlorines have a charge of 0. And carbon has 4 valence electrons minus 1, 2, 3, 4, 4 bonding electrons. And I know that because there are 4 bonds attached to it, even though one is a double bond, still counts as 2. That also equals 0. So in this question, I have now met all requirements and it should be complete. The way the AP exam works is that when you answer part A, they are generally going to use the next portion, or they're going to connect all of the parts of the question together. So for example, here we have part B, and it says, although the atoms in the Lewis diagram for the CO molecule obey the octet rule, the formal charge on each atom is not 0. So based on the structure that we drew, so based on what we did in part A, we're going to have to calculate the formal charge of each atom. All right, so in this case, if I had made a mistake in part A, it would now be quite detrimental to part B because I can't possibly answer part B correctly if part A is incorrect. Though in this case, part A is correct. Okay, so I'm just going to redraw what we have so we can look at it. So that's CO for carbon monoxide. You might have a detector in your home. And let's go ahead and calculate the formal charge. And we use this formula on the last page as well. So we said the formal charge is the valence electrons minus those lone electrons plus any bonding electrons. Okay. Carbon has 4 valence electrons. And let's go ahead and start subtracting here. There are 2 lone electrons right there. And I'll go ahead and erase that. So it's, I guess that's okay. So that's 2 plus the bonding electrons. So 1, 2, 3 from the 3, it'd be like this, 1, 2, 3. So that's plus 3. Well, 4 minus 5 is -1. So the formal charge on carbon is -1. Y'all are going to be experts on formal charge calculations now. Okay, oxygen has 6 valence electrons minus. It also has 2 lone electrons here, so 2 plus 1, 2, 3. So this time we have 6 minus 5. Okay, so that's going to give this a +1 charge. And when I'm considering whether this could be correct, it makes sense because a -1 and a +1 would cancel out to 0, and there's no indication on this molecule that there is an overall charge. So it makes sense that your formal charges would actually cancel each other out in the process. And the last part of our question, this one is specifically asking us for information regarding the COCl2 molecule that we drew. All right, so I'm going to redraw this. We had it here. So I'm going to redraw this part. And I'll do it in green. Okay. So first, we're being asked to find the molecular geometry. Then we're going to be asked whether or not this molecule would be considered polar. And finally, it wants to know about the number of sigma and pi bonds. So when I'm reading this, I might quickly make myself a note. Oh yeah, let me remember what sigma and pi bonds are, just before I kind of forget. So a sigma bond is, I often like to think of it as a single bond, though double and triple do contain sigma bonds. But a single bond is always going to have one sigma. A double bond, and that's all we need for this particular question because we only have single and double bonds, is going to have one sigma plus one of the pi bonds, but I'll make a note of that in the other section. And a pi bond, okay, single bonds don't have any, so single equals 0, and a double bond would only have 1. Okay. So knowing that, we can even work backwards here. It doesn't matter what order we do this in. One part does not affect the other. So if I was going to count the number of pi bonds, and I know that single bonds don't have those, and a double bond has 1, well, I only have 1 double bond in this molecule, so I would just have 1 pi bond present. Okay. For the sigma bonds, I see that I have 2 single bonds, so that will be 2 sigma bonds, and I have 1 double, which also contains 1 sigma bond, so that will be a total of 3. Is this molecule polar or nonpolar? When I look at this, I do see quite a bit of symmetry. However, these elements have enough of a difference in electronegativities that this should be a polar molecule. And the student should have a pretty solid idea of what I mean when I say that, since they won't just have lots of charts to look at while they're using or completing the AP exam. And finally, for molecular geometry, which they also likely already know this part too, this would end up being trigonal planar. And that is just because when we don't have any lone electrons on our central atom, we only have bonds, they're going to push each other away as far as they can because all of these electrons surrounding the atoms have negative charges. And negative charges are going to repel each other as much as possible when they're close. So they'll push as far apart as they can, and all they can do while being attached together is approximately 120 degrees. Okay, so I'm gonna go back to the Zoom meeting. And I will stop sharing my screen and I'm gonna turn my camera back on. I just wanted to give y'all a taste of what the students would experience as we work problems, though I do enjoy being quite interactive and I want the students to participate, to answer questions, to at least jump in and answer on the chat if they don't want to speak out loud, though I'll highly encourage students to speak out loud because this is going to be a space where it's safe if you don't know something right now. We are preparing so that students know as much as possible by the time this exam comes. And by interacting, by speaking with me and with the other students that are in the class, virtually, of course, hopefully we'll be able to clear up any confusions that might exist, any misunderstandings, and move towards everybody getting 5s on that AP exam. So Does anyone have additional questions they would like to ask at this time? Maybe you thought of something. Maybe you completely understood the lesson, and that would be really awesome. I'm not sure how many of you remember back to chemistry. But I'll just wait a moment and see if anybody has any questions they would still like to ask. So I'll give it another minute before moving on. Okay, so it looks like maybe there are not more questions right now. I'm going to share this again. We're going to go back to the presentation. Okay. Oh, it's going to make me start over from the beginning. That's okay. We'll just split through. So here is a reminder of the hours of operation for Momentum, so that if you need to go into the office for anybody living in the greater Houston area, or if you just need to call, these are the times that they will be available. Please note everything is in Central Time, and then you can also reach them at info@momentumlearning.org, and they're very, very fast at responding to those messages. As for the students who are going to be taking the course, in Canvas, which is the platform we're going to be using, there will be a way to actually message me. So students will be able to directly message me via Canvas. And then if you needed to talk to someone else from Momentum, this is when you would use the email or give them a phone call here. But students will be able to contact me through Canvas. And then I can put that up again if anybody needs it. Okay. So with that, I don't have anything else for y'all at the moment. I wanted to just give you a brief introduction to the course, and I wanted to let you see my teaching style so you would know what your children were going to be experiencing, or your students would be experiencing as they took the course throughout the semester. I really look forward to working with all of the students and helping them work towards that goal of a score of those 4s and 5s on the AP exam. And I'll look forward to getting started February 5th. So if you do not have any further questions for me, you can go ahead and log off, enjoy your weekend. And if anybody celebrates the Lunar New Year, happy Lunar New Year to everyone. I know that's coming up on Sunday. But if not, and y'all don't have questions, then you can always reach out to Momentum, or you can have your child contact me through Canvas as well. You're welcome. I'm glad it was helpful.